Hello, everybody. Welcome to this session of Apex Hours on Mastering Salesforce DevOps. So I'm Andrew Davis. I'm the Senior Director of Research and Innovation at Copado, also author of the book Mastering Salesforce DevOps. I have a bunch of Salesforce certifications, worked as a developer and an architect, formerly as part of Aperio, and then over the last 2.5 years, I've been part of Copado. So I want to just cover these topics today. Obviously, this is going to be a fairly large amount of material, but I'm going to try to condense it down to just the essential points. So I want to start by helping everybody to understand, why do we need DevOps? What are we talking about anyway? Why is this important? I want to talk about, how do you measure and visualize progress in improving the software development lifecycle. I'm going to talk a little bit about continuous integration, a little bit about continuous delivery, just to make sure that everybody has an understanding of what these practices are really about, and then talk about how to make progress over the long term and the importance of that. So, by the way, just a word about Copado. Copado is the leading Salesforce DevOps solution. I've got over 1,000 customers supporting every aspect of the Salesforce development lifecycle, including now automated testing, UI-based testing with Copado robotic testing. If you want to find out more about DevOps after this session, go to Trailhead. You'll find 2 Trailhead modules. I wrote those modules on behalf of Copado. So really good way to get a grounding in some of these basic concepts as well. So first of all, I want to cover, why do we need DevOps? What is this all about? And I want to start by thanking you because you have an important job, and maybe your job is learning how to do an important job, or maybe your job is actually helping a company on a regular basis, building code or configuration. It's a creative job. You're hands-on, actually building the capabilities that your company needs to run smoothly. And is really powerful what you're doing, because you have a big impact. If you think about, you may just think, oh, I'm just one person doing one small part of the job. But if you think about what you're doing, let's say you're on a Service Cloud team supporting a Service Cloud app, right? So that Service Cloud app is going to be used by some Service Cloud users, customer support agents, for example. And they're serving lots of customers, but there's actually many Service Cloud users, and they each have a lot of customers. And so directly or indirectly, if you look at this, you can see that the work that you're doing is actually impacting typically hundreds or thousands of people, in some cases millions of people. That the development teams have an exponential impact on the company, and it's really important to appreciate that. And if you ask, what is the most important link in this chain, if you just think about that, I'm obviously biased, but I really think it's your ability to roll out changes, your ability to actually effectively make changes to every part of your org is critically important. So for this reason, you need good tools to do your job. You also need good processes and so forth, because what you're doing is very important. So you've got Salesforce, and Salesforce obviously is a fantastic tool, easy to build on. You've got all these declarative schema builder and flow builder, app builder, and all this good stuff. Easy is great, right? But some conditions apply. So there are some side effects of easy. So the trouble with easy is that easy means it's fast. Fast means you create more of it, more innovation. But the problem with more is that it piles up and it becomes quite complex over time. So the idea is that building in Salesforce is like building with Lego blocks. And over time, you can build something amazing like this Salesforce tower. But if you're like a lot of companies, a lot of their orgs look more like this Jenga tower, where it gets a little bit precarious, and increasingly making even small changes becomes highly risky. And so that's really where we want to talk about DevOps, and this becomes so important. So let's just take a step back and look at what's called the development lifecycle, just that whole process that you're following to build apps in Salesforce. So let's start in the simplest case. You've got one production org. In that production org, you build changes, you test them, and you run things. And that's the simplest way to get started, right? The problem is if you're doing everything in production, there's a pretty high risk of failures. Once you get users in there and you start building new stuff and testing it in production, it's a high risk of failures. And that can, cause problems for your company, such as, other people can't do their jobs, you can't sell, you can't service, whatever. Lots of bad things happen. So what do you do? So that's bad option number one, is not having any process. What do? You move to sandboxes. Sandboxes are incredibly helpful. Salesforce has a better sandbox system than a lot of these big enterprise clouds, development, test, production environments. But the challenge that you encounter when you're running on sandbox is that it can be quite hard to deploy from one environment to another. And especially if you've got to do like configuration data, if you're working on, velocity metadata or complex apps and so forth, that stuff gets hard, right? So what do we do when stuff is hard? You procrastinate. You try to do it as infrequently as you possibly can. So what happens if it's hard to deploy, you're not going to deploy very often. When you don't deploy very often, stuff piles up, right? And then when you do deploy, you have really big deployments. And when you have big deployments, what happens is that there's a high risk of failures. You deploy, one component at a time, pretty low risk. If you deploy 500 or 5,000 metadata component changes, it's a very, very high risk when you make that deployment that you're going to break something, and it's going to be very, very hard for you to figure out what you broke. So what this means when you have these really big deployments, like a release day, you have to have a lot of coordination, get multiple people together, working together, and you got long test cycles. You get a lot of people in there testing a variety of stuff, and then that actually slows things down further. So you make this into a big project. Every release is a big deal, and then you can't do it very often. Now, the other problem with deploying infrequently is that you get delayed feedback. So you build something, and then it has to wait days, weeks, maybe even months before you have anybody actually using it, before they're actually generating opinions and telling you, hey, could you move this here and could you move that there? And this calculation was not quite right. And so forth. So delayed feedback is really problematic because what happens while you're waiting is you forget exactly what you did. And if somebody tells you to make a change right when you're working on something, super fast and easy to make that change. If they tell you a week, 2 weeks later, it gets a lot harder. You got to remember how it all works and so forth. So what happens, you end up getting pretty poor quality, relatively poor quality, because you're not getting a fast feedback loop. Poor quality, you try to fix it by better testing cycles, but then you end up just, delaying the project further. And then again, you've got a bad situation where you're really not optimized. It's not as much fun for you. It's not as beneficial for the company and so forth. So bad option number 2 is having a slow process. No process, bad option, slow process, bad option. So the first thing you need to tackle when you're looking at DevOps is making deployments easier. Now, it gets a lot deeper than this, goes into lots of different aspects, but that's the first blocker. And when I talk about this blocker, I'm really indicating something called theory of constraints. And theory of constraints is very, very popular theory within the DevOps community. It's the idea that in any given system, there's always one and only one constraint that limits the throughput of that system. So that may sound a little bit fancy, but imagine you've got a hose where there's water flowing through and you've got a big wide part, and then your car drives over part of the hose, and so it's partially blocking the hose. The whole throughput of the hose is limited by the one constraint, the part where the car is resting on the hose, so to speak. So in most Salesforce DevOps teams, the main constraint is their ability to do deployments. Now, that's not always the constraint. The constraint can move around and so forth. And that's what's called the theory of constraints. So you've got to figure out what is the constraint on the system that is enabling work to get done by you, by your organization, and figure out how to unblock that constraint. That's step 1. Now, step 2, as soon as you unblock the constraint one place, something else becomes the constraint. And so you're always moving to identify and unblock that constraint. And there's always, the constraints moving, but you're getting better and better and better, right? So you're making massive improvement. You're making improvement by targeting the one area where where your team really needs help. So if we think about this on a big scale, like why did we move to Salesforce? If you think about what is the constraint on delivering ideas, because if you're a Salesforce developer or admin, that's actually what you're doing. You're basically taking somebody's idea and you're turning it into reality. So imagine all these little blue dots are ideas. How many of those ideas can you turn into reality? So in the beginning, you might be facing technology constraints if you've got to, custom code every single thing you want to build. And that's why people move to Salesforce. People literally move to Salesforce to unblock the constraint on their ability to deliver ideas. But, the next constraint you might hit is maybe you don't know how to build on Salesforce quite as well as you could. And that's why you head on over to Apex Hours and you learn, improve your skills. You go to Trailhead and you study and learn. And with these learning resources, you further unblock your constraints. You increase your ability to deliver more. Maybe your team's still too small. Like everybody on your team's, working hard and they know what they're doing and so forth. There's only a few of you. So then maybe you hire a consulting company. That's a common solution that companies do to increase their capacity. But at some point, maybe you work for a consulting company. At some point, you realize that it's not a shortage of people that's holding this back. It's something in our process. And that's where DevOps comes in. DevOps is about optimizing our process through the use of supporting tools as well, and culture changes and so forth, so that we really can maximize our capacity to deliver ideas. So if you look at the power of DevOps across the industry, it's really remarkable, the kinds of improvements that are made by teams that do a great job compared to those that are not high performers. So the high performers or elite performers are able to deploy typically 200 times more frequently than low performers. Far shorter lead times, far fewer change failure rates. If they do have issues, they can recover much more quickly. So very, very powerful. So when you talk about DevOps, that people throw that word around a lot. It's good to have a little bit of sense of where it comes from. Sometimes it's traced back to the original a talk given at a conference called Velocity by John Allspaw and Paul Hammond in 2009. 10 deploys per day, dev and ops cooperation at Flickr. The idea that the development team who builds new stuff and the operations team that helps keep systems running in production, figuring out how to cooperate. And so this is one of the big innovations in the DevOps movement, cooperation. So cooperation takes a wish to cooperate, takes good, clear communication, and then you can begin to layer in, shared tools and shared visibility and so forth. And so you can see how cooperation really is rooted in, do you want to cooperate? Are you happy to get along with people? Do you want to communicate? Do you want to make everything better for the company? And then you can begin to layer in, version control and automated deployments and all this fancy stuff on a technology level. But that's the beautiful thing about the DevOps communities. It really does address this whole variety of concerns from lean software engineering to transformational leadership to techniques like continuous delivery to optimize quality, reliability, stability, and security at ever lower cost and effort. That's a nice, concise definition of DevOps. So, going the wrong way. So the idea here is you've got this developer over here on the left and this operations person here on the right, and you've got what's called the wall of confusion, a very famous old diagram created like this. Now, why on earth would there be a tension between these two groups? For a very good reason, because they want completely opposite things. If you're a developer admin, what do? You develop stuff, you build stuff, you make new things, you change things, right? Now, if your job is operations, which literally just means keeping everything running, the number one most reliable way to keep things running is to not change them, right? Keep everything stable. If you never do any deployments, if the system never changes, easy to keep it running in most cases. So these groups literally want completely opposite things, change versus stability. So what we really want, though, of course, is we want both. We want to be able to change when we need to, but we want to be able to do it with low risk. And so that's how we need to balance these. So one of the key things to touch on in the DevOps community that you may encounter if you look at other resources and so forth is the idea of measuring progress. I mentioned some quotes early on, and those quotes I mentioned some statistics earlier on. Those statistics are what are known as the 4 key metrics of DevOps. These are not the only metrics that matter, but it's one of those nice things where there's only 4 of them. They're pretty easy to remember. And so the whole of the DevOps community, a lot of the software development communities kind of rallied around these 4 metrics to figure out how they can optimize the performance of their team. So these first 2 metrics on the left, lead time for change and deployment frequency, those relate to dev, if you want. Those relate to your ability to roll out changes quickly. Lead time literally means from the time you build something, you finish working on it, into the time people are using it in production. How long does that take? Is it an hour, a day, week, month? That's your lead time. The second one, deployment frequency. How often are you deploying? Are you deploying once a month, once every 2 weeks, every day, multiple times a day? Why does that matter? And certainly if deployments are hard and they're not fun, the idea of deploying every day sounds like the worst idea in the world. Why would you want to deploy every day if deployments suck? So the first thing you have to do is make deployments not suck. Then, why deploy frequently? It's what I mentioned earlier. If you deploy frequently, you're deploying a very small number of things at a time. You make one change, you get it out there. A lot of the changes you need to make in Salesforce, for example, are very low risk. They can be done quickly and so forth. You need to test them, make sure they're right, but there's no reason to delay them, and you can move those changes out quickly. When you start having large batch releases, as we say, there's a lot of risk in each of those. You're changing tens, hundreds of things. If something goes wrong, you've got to sort through tens or hundreds of things and their interactions to figure out what went wrong. So that's why deployment frequency matters. And these 2 metrics on the right, change failure rate and time to recover, they relate to stability. And change failure rate literally means every time you roll out a change, how often do you break something? Hopefully almost never, but sometimes when you have a really big deployment, some teams, every single time they make a deployment, they break something, right? Something in the org broke because there's so much change happening at a time. And that's why small deployments reduce the risk of every individual change and also make it a lot easier to fix. And that is what we refer to as mean time to recovery. So this 4th metric, mean time to recovery, is when you do break things, how quickly can you recover? How quickly can you fix them? So these are known as the 4 key metrics of DevOps. And they're, again, not everything you need to think about, but they're a nice set of 4 metrics that touch on some considerations that balance each other out. Now, I had an opportunity to participate in and run the State of Salesforce DevOps report, and we'll be doing another one in the next few months. One of the things we found is that there were, in the Salesforce world, again, these elite performing teams, high, medium, and low performing teams. We were able to identify teams that did a fantastic job at rolling out innovation quickly and safely, and teams that did not do a great job at rolling out innovation quickly and safely. So we asked another question in this survey. We asked not only how quickly and safely and reliably are you able to roll out changes, but we asked, how's your company doing? Now, for companies that have only a small Salesforce team, we didn't see any real relationship between how well their Salesforce team was able to roll out changes and how the company was doing. But as soon as we started looking at companies that had 25 or more people on the Salesforce dev and admin team, we saw this correlation, that the teams that were very low performers in terms of their software delivery, also the companies weren't doing as great. And the teams that were high or elite performers in terms of their software delivery, their companies tended to be meeting or exceeding their goals. Not saying you can attribute everything to the Salesforce development team, but it really helps. If you're running your business on Salesforce, you have to be able to make changes to Salesforce quickly and easily, right? And you have to be able to do it without breaking things. If you break Salesforce, you break the business. That is a big deal. Right? If you can change it easily, then your business can change easily and you can roll out new processes and you really get a lot of value from the platform. So now I want to actually go into some of the mechanics or the details of DevOps. Dev and Ops is worth talking about. Dev first. I'm not going to tell you how to develop on Salesforce. There's a lot of other great resources, Trailhead and Apex Hours and so forth. Lots of supporting resources to help you to learn. But what I am going to talk about is some of the things that are not as frequently discussed. And I'm going to start with architecture and a couple of great quotes here. And I love these pictures. Control your architecture or it will control you. So what's the difference between developing on Salesforce and working on the Salesforce architecture? Well, there's not a clear and clean line. It's a little bit of a make-believe line. But basically, architecture are all of those parts of the system that are hard to change later. These big decisions that you make where a lot of other decisions end up being dependent on those decisions. A couple of great quotes here. If you think good architecture is expensive, try bad architecture, and that most architectures are accidental, not intentional. So in many cases, architecture can really be the main constraint. And I've had a lot of nice opportunities recently to talk to teams that had done a great job with their Salesforce DevOps processes. And from their point of view, it all starts with architecture. If you do a really good job with architecture, it's really easy to move your changes. So the main thing you want to think about in terms of, so to speak, bad architecture or good architecture is this concept of tight coupling. So tight coupling makes it really hard to move changes independently. And if you've heard the term spaghetti code, right, that's where it's really hard to understand, this calls that and so forth. And I've seen some pretty horrible code written in Salesforce. A lot of people who are starting in Salesforce, they're, a little bit new to coding. And so it's really easy to just write an Apex class that just goes on and on and on and on and on. Impossible to understand what that's doing, right? There's this rule called the 10-100 rule where you don't want to have any single method that's longer than 10 lines and any single class that's longer than 100 lines. It's a rough guideline, but it's really powerful if you just give yourself a constraint like that. Everything should be small, before one function, call each other, make things very clear. But that's just within the code. There's levels of coupling also, this class calls that class, calls this database object and so forth, that can make it really hard to understand exactly how your system is working. And that's one of the powers of Salesforce DX, is that it allows you to divide your code into subfolders and then gradually into packages and so forth. And that enables what's called loose coupling. So you think about the pizza analogy compared to the spaghetti analogy. So pizza, loosely coupled, you can pull a slice off, you can stick it in your mouth. I'm getting hungry just looking at this. So things like object-oriented design, but importantly also modular architecture. This is the idea of being able to divide your work into subfolders and turn those subfolders into packages and so forth. That makes everything a lot more flexible, partly because it enables different teams to move at different speeds. So if you can break the system apart, then you can limit what's called the blast radius, right? If you do have a failure or an issue, you know exactly what it's impacting. So architecture is really where it all begins. And then you get into these concepts like continuous integration. So what is this? What's continuous integration? Well, I need to start by explaining version control. So version control, 6 years ago, when I got started in this stuff, 7 years ago, when I started focusing on this, it was not at all common for people to use version control in Salesforce. Times are changing, and that's really, really good news. There's a lot of tools out there that help you to track work in version control. Um, Git is the standard that everybody tends to focus on. Just use Git. There's an easy way to get started with version control, and that is taking what one of my colleagues called defensive version control, just taking snapshots, like just capturing all the metadata, having an automated process that captures a snapshot every day about that metadata. At least that gives you a history. But what you really want to move towards is every time you're making changes, this is called offensive version control, intentionally tracking those changes. And um, that's where all this stuff starts, right? Any further kinds of automation, if you want to automate tests or deployments or whatever, you really need version control. If you don't understand why, take my word for it. You do. You really do need version control. We can have a longer explanation, but basically without version control, you're flying blind. You have no idea who changed what or why. You come to some piece of code and you're like, did somebody change this? When was the last change? Or who wrote this line? Or what was this line of code about? And so forth. You have to have that knowledge if you want your world and life to make sense. So you've heard about this term continuous integration. People talk about CI and CI/CD, and they use these terms very casually. Continuous integration means never letting any two developers or admins in your project get out of sync, get too far out of sync. Yeah, you can have your own sandbox or scratch org, and you can work independently of others for a little while. Merge that work at least every day. And don't let things last and linger for like days, weeks, where you've got changes that you're making and you're not merging with the rest of the team, because for a lot of reasons, but the main reason is that it makes it extraordinarily hard to make deep changes to the code base, to refactor the code base. And so what happens is with code, you really need to be constantly refactoring it, constantly making small adjustments to make everything more sensible, more efficient, and more clear. If everybody's working in one software trunk, then you've got one system where you need to make changes. You make a change one place, everybody's got that change within a day. If you've got teams that are not merging for days, weeks, months, it becomes really expensive in terms of time and pain and risk to eventually integrate their work. And so people can't make deep systematic changes. And you end up getting a very rigid code base, as opposed to one that's living and fluid and flexible and changeable. So you can think about continuous integration as falling into this nice spectrum. It's a complicated graph, but just sort of look at the green and red bit. If everybody's working in the same sandbox, and as soon as somebody else changes something, your system changes, there's a possibility that they break something you were working on, and that you can spend hours just being confused about why did your thing stop working. And that's a little bit too frequent, right? It really is helpful to have a separate environment where you can make changes separate from others, so you can know if it stopped working, if something broke, it was your fault. It was not something that somebody else did. So you just have to retrace your steps and undo whatever you did last, and then you can fix that issue. Otherwise, if everybody's in the same sandbox, things can break, and it can take a lot of energy and work to figure out who broke it, how does that work, and not good. So a little bit too frequent. So having multiple environments allows you to not have instantaneous integration. But again, like I said, if you're waiting days, weeks, months to integrate, that's too inefficient. So too unpredictable or too inefficient, and you want this nice sweet spot, continuous integration, the Goldilocks zone. All right. So continuous integration really puts pressure on testing. So if you think about what the company requests, like the tip of the iceberg, but what you actually build is like all of this stuff underneath the surface. And so when you think about quality and testing and so forth, you've got these two aspects. The parts of the system that people can see are functional quality. They relate to functional quality. This question of does it do what it's supposed to do? But all of the stuff that's beneath the surface, right? How you wrote your code. Did you document things? Do you have, description fields filled out? Is it secure and so forth? All of that is structural quality. And you've got these 5 categories of structural quality: reliability. Does it break easily, right? Security. Is it vulnerable? Performance. How quickly and efficiently does it run? Maintainability. Is it easy to understand what's going on and maintain it? Size. Basically just means the bigger things are, the harder they are to maintain and the more risk there is. So keep things as small as you can. So continuous integration puts pressure to optimize for testing, because if you're merging on a regular basis, eventually manual testing becomes impossible to keep up with. You really need to layer in some automated testing. And that takes us to this next topic of continuous delivery. And so often people say CI, CD, but of course they're very different things. CI and CD, it's just they sound similar, so people clump them together. But you need to get a sense for what continuous delivery really means. And to understand the purpose of continuous delivery, you need to understand this concept known as configuration drift. Nice, technical term. If you're not familiar with this term, you've learned a new phrase. Configuration drift is what happens when you have a production org and then you clone 2 sandboxes or 3 sandboxes. You clone your dev 1 environment, you clone your dev 2 environment, you clone your test environment, right? All 3 of those sandboxes are exactly alike when you get started. And then you go in dev 1, you start making changes, and you take some of those changes and you move them to the testing environment. And then your colleague gets in dev 2 and they start making their changes, and they take the important changes and they move those to the testing org. So now your org has the important changes you made, and then maybe a few other changes that you weren't important, you didn't want to track, right? And dev 2 has the important changes and then a few other things that weren't that important, you don't need to track. And then the testing org has the important changes from dev 1 and dev 2, and it doesn't have any of the other stuff in dev 1 that didn't get tracked. It doesn't have any of the other stuff in dev 2 that didn't get tracked. And it's quite different from production. And those 4 orgs are extraordinarily different. And so things behave differently in different sandboxes. So it works in your org, it doesn't work in dev. It works in dev 1, it doesn't work in dev 2, it works in testing. It gets chaotic, right? This is what's called configuration drift. You could talk about entropy as this scientific term of things just getting more different over time. And you end up wasting a phenomenal amount of time. It ends up being incredibly inefficient. And so it's critically important to be able to synchronize these orgs and cut entropy and cut this idea of the differentiation. That's why scratch orgs are so powerful, because whatever was in sandboxes live forever in many cases. Scratch orgs, they kill them and they cut all of that complexity. You start fresh on a regular basis. So it reduces configuration drift. That's one way to reduce configuration drift. Other ways are just having a very well managed development lifecycle and practices like continuous delivery. So continuous delivery deals with this right-hand side of things, whereas continuous integration is about integrating the developer's environment. Continuous delivery means getting your work out to production as quickly as possible so that you're reducing the variation between these orgs. And there's going to be a little bit of difference between the orgs at all times, but you want to keep that difference constrained. You don't want to let your testing environment get too far different from production. You certainly don't want to get production too far different from your testing and development environment. You need to get control over all these environments. And that level of control is, that's what we call success in the DevOps world. So you think about continuous delivery really operates under this sweet spot here. And although you need to consider other things, like if you're rolling out changes, you have to think about the timing of making sure that the users are ready for your work. I've got a quote in the book, Mastering Salesforce DevOps, that the reason you might not want to release all the time is that either your work is not ready for users or your users are not ready for the work that you've done. So delayed deployments are quite problematic and inefficient. So you've got, this is a screenshot from Copado, for example, that allows you to visualize all the different environments and in particular to be able to visualize the number of changes that are moving back and forth between these different environments to keep the differences small. This is a screenshot from a mock-up. It has very large numbers, but you would never want like 600 differences. I need to update this slide. We've got all these numbers are way too high because it's just a mock-up, but you want to reduce the number of differences. But first of all, the main thing is getting visibility into what those differences are. So when we talk about, so we talked about development, we talked about delivering changes. Now we talked about Salesforce Ops, right? To complete this discussion about DevOps. Salesforce Ops, Salesforce does that for you for the most part, right? They're the ones who are holding the pager in most cases. They maintain the servers and the networks and so forth. And so when we talk about a Salesforce admin, in many cases, they're really developers. They're just click-based developers as opposed to code-based developers. But Salesforce admins do have a lot of opportunity to help make things better. And here's where we get into a slightly sensitive subject, the idea that if you're an admin, you kind of expect to have admin access to your production org. And you think, well, I'm an admin and I've got my Salesforce admin certification. I should just be able to make changes directly in the production org. Why should I go and make my changes in the development environment and have to deploy it and so forth? Well, for a lot of reasons. And so there's massive inefficiencies that come, as I just said, if your production environment gets out of sync with the development environments, and it ends up slowing everything down for everybody. So if there's admins in production that are making, you can make changes like, changes to email templates and dashboards and reports and so forth. But for almost every single change that you're making that are important, you really need to be putting that into a development lifecycle. You need to be doing that work in a development sandbox, moving into testing, moving into production. If you think, oh, that sounds like such a pain in the butt, that means that you need to make that process easier. The developers, Salesforce coders, have to follow the development lifecycle because you can't write code directly in production. You've got to deploy it. Everybody should be following that development lifecycle. And also you should be looking at tools like Copado that have a admin-friendly UI that make it easier for people to expedite this development lifecycle. So I just want to finish here by talking a little bit about change and how teams roll out change. Now, you may be a hands-on developer. You may be, maybe not. You're responsible for managing a team, et cetera. But as you develop more responsibility in your company, you begin to need to understand things like this about the way in which people adopt new ideas. That this bell curve is what's called the technology adoption life cycle. And it, if you've ever heard the term early adopter, like I'm an early adopter, I always like the newest releases of whatever. So this is where it comes from. It comes from this idea that there's some people right at the edge, bleeding edge, innovators creating new stuff. Then there's early adopters who use it, fairly early on. There's an early majority and a late majority, and then there's laggards, people who are, who will do something only when everybody else is already doing it. So there is this idea of a chasm where it becomes the things that people get really excited about, the nerds, like a new technique, maybe Salesforce events. You get really excited about platform events, and then you've got a few people who say platform events is the future and so forth. But have you rolled that out to all of the teams developing on Salesforce? If not, if you couldn't convince other teams to develop in that kind of way, it's because you fell into this chasm. Because what you need is a change management process that actually gets other people excited about the idea of rolling out change. And so in my book, I talk through this this idea, this 8-step process that comes from John Kotter, um, about how to lead change and how to systematically promote ideas and roll out change across the company. Y- Back to that original slide where you've got an important job and you're having a big impact on the company. Um, we need to understand more than just building technology. We need to start to understand how humans work and how we think and how you can help people to change and how you can promote an idea, how you can make things easier for people to adopt. And all of that really becomes part of helping the organization and the development team become much more effective and efficient. So, my final words to you are communicate well and be bold, be brave. Uh, there's a lot of learning we all have to do. There's a lot of change that has to happen. We need to um, get the best ideas, gather the best ideas, learn them, share them, help everybody to succeed uh, in these challenges of developing software in Salesforce, and have fun, have a great time. So I'd love to invite you to read my book, Mastering Salesforce DevOps. It's a big book, but it's a really good reference. And so hopefully you'll enjoy it. And I'd love to invite you to follow up with all the other great resources that Apex Hours has to offer. So thank you so much again. My name's Andrew Davis. It's been a great time having a chance to meet you and connect.